Welcome to the AI Engineering Bootcamp, cohort number 5. We're in session 13 in week 7. Time's flying. Midterms are in. Good job, everybody. I'm sure that was a bit of a brutal weekend, a bit of a brutal week, but you got it done. Time to keep pushing, time to keep moving, time to keep the building, shipping, and sharing going. I want to do a couple quick shout outs, just a couple real quick ones. Shout out to Ben for actually putting Seek 3D, his demo day project, his midterm project out there, and really getting out in front and leading from the front. You've got some momentum going, Ben, and I'd love to see this. We were able to even showcase this in the newsletter. I look forward to seeing all the building, shipping, and sharing going on this week with you guys based on the submissions that you just turned in. Also, I just want to give a quick shout out to Piotr, who was in our last cohort. He really hasn't built, shipped, and shared very much since graduating, but he went out and he really built a very, very cool app. He was finally ready to build, ship, and share something. Sometimes you got to go into build mode for a while after you learn all this stuff. Came out strong, joined us the session on Monday, and really, really, really love to see this. This is the kind of thing that I look forward to seeing from each and every one of you as we continue our journey together to create the world's leading community for people that want to build, ship, and share production LLM applications. Okay, homework coming back to you guys, fine-tuning embeddings, some high submission numbers. You guys are maintaining that. Not everybody did a perfect job, but overall, seems like it went pretty well. What'd you think, Mike Dean?
Gotta find my mute button. One thing I would say is that there are notes and hints that are in these notebooks. Little notes that say this is an AI engineering course, and you probably know what ChatGPT is, and you could paste the above text into ChatGPT and get the answer. Those are useful to take. The instructions are important. The back end of this assignment was to duplicate the Ragus evaluation precisely as had been done in a previous notebook, and a number of people failed to follow that instruction and did fragments of it, didn't complete it. And then a lot of people get almost to the end of their Loom video and they don't finish, and it cuts them off. And our rubric is that's a point off. And if you've got cut off, just re-record it. It's unless you're willing to take a point off because you got to the end. And then GitHub repositories have to be public. I ran into one that was not only not public, it wasn't even findable on GitHub. And so I wasn't able to evaluate the notebook except through the Loom video, which is going to be suboptimal. So nothing you haven't heard, but same messages.
Thanks so much, Dr. Dean. Appreciate your insights. Guys, we are working hard on the back end to make sure we get high quality feedback to you. So yeah, do follow the tips and tricks as we continue, especially as we get into more advanced stuff. I saw a lot of great lessons learned here. Fine-tuning embeddings can improve the performance. That's what it's all about. Evaluating the retriever versus the actual response. So the embedding model, the retriever versus the LLM, the generator. This is a great distinction to make. Chunk sizes and fine tuning, you can get a long way with it. We'll talk more about this today. Some of you feel like you need a new computer after some of this. Lessons not yet learned. These are good questions to ask. What about overfitting? What about fine tuning best practices? What about, should I definitely do this or not? Well, like all great questions, it depends. Amazing job sharing, everybody. Keep it going. You guys are crushing it. It's just one more step to get it out there in public and start building that brand. We see folks out there like Ashwin, like Catherine, like Kenny. We see Krishanu continuing to put it out there. Deep T, pick your platform and start amplifying your own personal brand. Okay, so this week, tomorrow, we've got a very special event. This should be kind of a blast if you want to join us. Wiz is going to get into some deep vibes and do some vibe coding. So it should be really just a lot of fun, and hopefully you'll learn something that you can take with you and use in the course. That's live on YouTube tomorrow at 10 a.m. Pacific. We got your feedback. You liked the AIM games. Let's go. You liked the pitches. Of course, these are the people that stuck around till the end. So, there's some sort of, bias there in terms of the sample that we got on the feedback. But overall, you guys seem to have a lot of fun. You guys seem to enjoy it. That's great. I love the suggestions. I also love GatherTown. We're looking for the right time and place to start messing with it. It's always hard to push people to a different platform, so thank you for the donuts and Gather Around. In fact, Gather Around, we will whip that out at some point in this cohort by the end of the day, and by the end of the cohort, I should say. And then, I really just like this all around, this kind of feedback. You guys wanting to get together is super great. And in fact, if you're looking for a place to be able to get together with us, we will be live at the Toronto Machine Learning Summit in June. This is actually an old preview link. They're still getting it together there. So I believe it's June 17th, 18th, 16th, 17th, 18th. So mark your calendar. We'll keep you posted. We can't get together in Toronto. You can see the whole squad there. So if you're local, maybe that makes some sense for you. I loved it. I love this kind of feedback. We always have time to network in groups in other communities. I'd love to hear more about that. You guys want more quizzes and a mandatory multi-agent system app every week, Wiz. That's an epic one right there. Theme-based event mixers, tell me more, and more time to build for the midterm. Yeah, always more time. Shout out to Mike Dean, Mike C, Todd LLM for helping out with the midterm in crunch time. Love to see that. And with that, let's go ahead and get into it. This is our very last week that we're going to spend on prototyping. So we're talking about advanced techniques now. We're talking about advanced retrieval, and we're also talking about advanced reasoning. Now, we thought about what we were going to do with the advanced reasoning session. We're actually going to build what just came out as an open source deep research application with LangGraph, uses reflection agents, uses planning agents, uses all the good stuff. So we're going to do that on Thursday. Today we're focused on RAG though. Today we're focused on the retrieval part of RAG, as we focused on during the AIM games. So next week we kick off our production part of the course, and this should also be a blast too. So now that you've got your GitHub, you've got your basic demo, you've got your basic RAG application, we can really start to refine things and take it to the next level, make it production ready, make it production grade for demo day. It's going to be a blast. All right, so today we want to really understand sort of retrieval chunking. We want to understand how we can assess what kind of retrieval algorithm we should be using and what we should just pull off the shelf as a starting point and how we should baseline, how we should go from there. We already have some insight into a lot of this, but this is going to really sort of round out the edges. Because when we talk about chunking, when we talk about retrieval, when we talk about ranking, these are different things, but they're also quite similar and quite related. And we start to see, as we overview this kind of topic, the broad sweep of patterns and how they can affect our applications really throughout the entire stack. Okay. Advanced retrieval and chunking. That's what we're talking about today. We're going to build, and then we've got a challenge for you to talk about how to evaluate. We're going to focus on the retrievers and the chunkers. But first, let's talk about RAG. And let's just root this discussion we're going to have today in our foundational idea of the importance of RAG. We want to have fact-checkable output and responses. We don't want false responses. We don't want hallucinations. We want to find reference material, we want to add that reference material to our context, and we want to improve the generations that we would get if we didn't have that context. So we do retrieval, typically with dense vectors, and then we're going to do in-context learning. Okay, so ask a question, go to the embedding model, find similar stuff, return a top K number of references to the context. This is simple naive RAG. And then this simple naive approach is where we use this dense vector approach. And then this in-context learning piece stays the same all along. RAG is almost done, but then we go to the generator, which is different than the retriever or the embedding model, to get our final output and our final answer. One of the things that I want to talk about is chunking, okay? Obviously, very important topic. Most importantly, chunking and retrieval are fundamentally linked. And so if anything you do in chunking is going to hit you downstream in retrieval, and there's many different chunking methods. In fact, you could imagine and create agentic chunking methods. I wouldn't necessarily recommend you go out and do that, but you could, and there are such methods. Also, custom data pipelines and all this kind of stuff could be thought of as chunking, especially as you get into very, much more complex, different modalities of information and all that kind of stuff that you might want to retrieve. Multimodal RAG and all this other kind of stuff. Okay, we're going to focus on the recursive approach, the naive approach, and the semantic approach. Both of them are actually semantic. One of them is just very, very explicitly using semantic meaning to add some additional performance to our application. Okay, so naive chunking is going to leverage off the shelf, typically this recursive character text splitter. We've talked about this before. We still use like a size and overlap, but importantly, we want to split at double new lines, at new lines, at spaces, and then at characters in that order. And the reason that we want to do that is because we want to try to keep paragraphs together, and then we want to try to keep sentences together, and then we want to try to keep words together. And like, that just makes sense. We don't want to chop a word in half. That's a dumb chunk, right? So we want to be a little bit smarter than completely naive. So we want to keep this stuff together as long as possible. We want to basically try to capture the semantic relationship between the tokens, right? At the end of the day. And so if you take like a simple story, like a Down the Rabbit Hole Alice in Wonderland story, this is the beginning of the book on page 2, page 3, you can see like a typical chunk that you might get with a chunk size of 200 characters and an overlap of 0 with this recursive character text splitting. So we do a good job sort of getting the end of the sentence here. We do a good job getting the end of the word here, but maybe we wanted this word, if we were being like real persnickety about it, and maybe it's not perfect, but it's pretty good. It's pretty good. We can go further trying to capture semantic meaning, and this is where semantic chunking comes in. And the hypothesis for semantic chunks here is that really, if we could use embedding representations of individual chunks, of individual sentences, and we could consider those, and we could sort of group them together in sort of a nice similarity space, we could actually create more meaningful chunks. So, sentences are part of paragraphs, right? And so on. So, how many sentences should we be chunking at a time? Well, if we look at all the sentences and we calculate their embedding representation and compare them to the adjacent sentences, then maybe we should decide to chunk those sentences together. And this idea of sort of chunking and de-chunking and re-chunking is sort of fundamental in our advanced retrieval methods. So generally, we're going to split the doc into sentences. We're going to compare 1, 2, and 3, 4, 5, and 6, and so on. We're looking how similar are these chunks of sentences. If they're similar, keep them together. If they're not too similar, then actually let them be a chunk. Makes a lot of sense, right? So, split them, index them, group them, calculate, and then merge. Wiz will talk more about the algorithms as he gets into the code here. But what you'll find if you do this kind of semantic chunking is you'll find much bigger chunks than that 200 and 0 overlap. In fact, if you look at sort of the same type of representation that we just saw in the naive chunking, instead of page 2, we're on page 6 now. So we got a big old fat chunk starting from the beginning of the book to page 6 based on how similar these chunks are in embedding space. Now, is that good or is that bad? Well, you're probably not building RAG for down the rabbit hole, so you have to decide for your application. You know, that's versus this kind of page 2 setup, okay? And of course, we just used a bunch of extra compute because we had to calculate embeddings for each sentence. Was that worth it? Well, these are the trade-offs we need to talk about and make. This leads us into parent document retrieval. And the parent document retriever, the way to think about this is like it's the best case of using this semantic chunking setup. Well, what do I mean by the best case of using a semantic chunking setup? Well, think of the enterprise and think of a problem the enterprise might have. They're doing information retrieval and they're trying to gather all this information. They've got this pile of PDFs and Word docs and they put it all in a vector DB and they get some chunks back. Well, they might say like, well, what doc is this chunk from? It's just a chunk, just sitting there in space. Just a chunk in space? Like, yeah, where was that chunk from, right? Like, where exactly was that chunk? And so this brings up the idea of like the context of the chunk. And so if you think about a parent document retriever, the idea is we want to search for small, tight context, but we want to return sort of also the fluff around the edges, okay? And this gets into the broader idea of metadata, okay? So just you know, if we think about the semantic chunking, it's like if we looked at all the edges and we decided which to keep based on what was similar, that would be effectively kind of what we're doing with parent document retrieval. But metadata is so important here, okay? And metadata is an often misunderstood term, right? Metadata is just data about the data. In the enterprise analogy, it's which document was the freaking chunk from, right? And so basically we're saying like, where did I get the chunk? And when we dig through context, sometimes we end up in this sort of needle in a haystack space. And this is sort of the nature of the beast when we try to evaluate these kinds of systems. So it's important to consider chunking and retrieval. It's important to consider all of this that we're putting in context. In the context of our context, it gets very, very meta with the metadata, right? So the retriever can be kind of thought of as these two different things, chunking and retrieval. However, when we insert metadata into our chunk documents, the metadata is going to then flow into the retrieval system, be part of our vector store or set of vector stores, and we can use it to return the proper context, okay? So chunking and retrieval, in short, both affect context. Metadata, like meta context, you might even say, can be leveraged to optimize what we put in context. And of course, we know that because that's what we learned day one in this course. As we move from prompting, from simple in-context learning into RAG, we're trying to optimize what we put in context, right? We're just putting the right stuff into the context window. And it's not a surprise that all of the evaluation stuff that we see is so focused around this idea of context and having the context be right. These are RAG systems after all. Okay, so parent document retrieval is basically you want a parent doc, fat chunk, and then you want the child doc, children always split the parents, terrible joke, and then you want to return the parent doc even though you search for the child doc, right? So this is sort of another way to implement semantic chunking, but it's actually a retriever. All right? All right, keeping it going here. Now, I want to introduce BM25, Best Matching 25, with this problem. If we just use semantic meaning, we will miss exact matches. This is no bueno, okay? We do not want this because information retrieval is sort of built in the world of Google. It's sort of built on this idea of, can we return the words I'm searching for? And if we're not sort of inherently leveraging this whole world of word matches, it feels like we're leaving something on the table. For those of you that have studied NLP, this bag of words approaches, this kind of thing, this is well known to you guys. For those of you that haven't, just imagine you chop up all the words you have and just put them in a bag. We basically don't care about where they are relative to one another. There's no context, let's say. But it doesn't matter, because if we have exact query search terms and we can pull them out of the bag of words, this can be very useful. Imagine searching through a service manual, right? And the error codes table will come up if you search for like problem codes, et cetera, but TS 999 won't come up. It's a little bit hard to map that in embedding space, and a little bit unnecessary if it's a super specific error code. So we want to kind of get the best of both worlds, bring in BM25. This gets us into this idea of ensemble retrieval. And of course, ensemble anything just means you put a bunch of different things together, and it's a bit more heterogeneous. So an ensemble retriever is gonna collect from here, and then rank everything according to whatever algorithm it's using. In this case, let's consider the reciprocal rank fusion algorithm. This is a legendary OG algorithm, the RRF, from, shout out to the University of Waterloo, Canada, representing today. 2009, this Chad paper was only 2 pages long, okay? And basically they're like, hey, if we combine document rankings from multiple information retrieval systems, we get better results than when we use one system. It's like, okay, what does better mean though? It probably means higher performance. It probably doesn't mean lower cost, right? So that was a theory, that was a paper. It wasn't an application in production. So we want to keep this kind of thing in mind. Now, we start to see very interesting hybrid approaches today. And I encourage you guys to check a lot of these out, especially as you start building out on the edge. So for instance, you could imagine that using keyword search and dense vector retrieval in this sort of hybrid setup is going to be pretty good. Now, there's even more advanced ensemble setups. They use also a sparse vector search. If you look into Pinecone or you look deeply into other vector DBs, you'll notice they have these special sparse algorithms and all this other kind of, interesting jazz that they put on their products to sort of make it even more performant, yet also more efficient. So these methods, like we saw in classic machine learning, the ensemble methods end up being quite performant. Now, is it the right answer for your application? Well, is it the most cost-effective? Maybe, maybe not. Probably maybe not today. Now, this gets us into one of the things that we've already recommended to you guys. This idea of re-ranking. The reciprocal rank fusion does it, and anytime we're compressing the context and what we return in terms of reference material, we're doing this. We're compressing context. And this is, you take the paragraph, you want to shrink it down. You take chunks, you want to shrink it. This is just exactly the same idea of what we're doing at a small scale in the context window of references with Cohere's re-rank, right? We've already talked about this. We've already seen this. And they give you a, quote, semantic boost, a little boosty boost. Never heard anything doing retrieval. And, importantly, like embedding models themselves, if you look at the leaderboard out there, you can use them just for re-ranking. There are re-ranking embedding models. I mean, what do you think Cohere's re-rank is? Well, we don't know because it's proprietary, but, there are open source re-ranker models. And again, keep this in context. What's the meta context of all of this? Well, this is the entire transformer, the entire stack, let's say. This is from the GPT-2 paper. And this idea of we're putting in a bunch of tokens in natural language, a big sequence of text, and we're getting just one token out of an LLM. An LLM is just a compression algorithm at the end of the day, right? We're doing all this RAG to actually just pump out a little generated answer. So compression is something that should intuitively make sense within the context. Okay. Now we also want to look at, finally, the multi-query retriever. I bet you could guess what this does, especially after studying the RAG assessment framework. We take an LLM and we generate multiple queries from our initial query, and then we answer those queries. The algorithm is very simple. We just look at from different perspectives, and we take all the stuff we find from all the queries, we retrieve all the docs, and then we leverage all of them. There are other methods too. You should look at them. These are the ones we feel like you should start with. Here's what I want you to remember as we head into the demo here. Chunking and retrieval both affect context. We looked at some methods and talked about some today. Naive, BM25, re-rank, multi-query, parent document, ensemble. We talked about recursive. We talked about semantic. There are more, of course. Remember, a through line for this is that metadata is going to be useful, especially as your complexity increases. We need to use it if we have data from a bunch of different places. We need to know where it's from. We need to know which doc it's from. We need to know which database it's from. We want to know more. We want to get more meta about our data. For RAG, we want to track all of this. And, you know, now that we've sort of expanded our view here, maybe we can actually modify our definition to RAG a little bit. And we can say it's not exactly just dense vector retrieval. It's actually just information retrieval and putting the right stuff in context. And, you know, if you're going to pick up something off the shelf today, obviously you can start off with a naive RAG setup. And we've seen this actually with our clients in enterprise too. It's not necessarily a good idea to just leave keyword search out, because in fact, many enterprises, many of the companies that you guys have worked for, maybe they're not even leveraging keyword search well enough yet. Now, is that AI? No, it's IR. But is that your job as an AI engineer? Yeah, I think it will be at a lot of places. And I think it is today. And so if you're going to like pick up something off the shelf, you're looking for something that's very, very kind of gold standard to get started with, do a little keyword search, do a little BM25, do some naive RAG, go from there, think deeply about your problem, think about the retrievers you want to use. And then also, I would also recommend you guys check out, we did an event not so long ago on this new method from Anthropic. And we're not going to cover it here because it's just, well, we have plenty today. And it's not really a first principles thing. They put together what they called contextual retrieval, great naming, which is contextual embeddings plus contextual BM25. I'm just showing you this because this is the kind of thing you'll see out there after you get done with this boot camp that you'll have to go and try to figure out and try to digest and decide, is this actually useful for me or not? And this again is one of those methods that forces you back into the LLM, back into the embedding model, back into classic NLP. And so it's a very, very interesting method for those of you willing to go deeper. So let's talk about our build today. We're going to do an advanced RAG build, and we're going to use fun data. We're going to use some John Wick movie data. So any John Wick fans out there, smash the chat. 1, 2, 3, and 4. We've got metadata on the 4 movies. Taking this down from IMDb, we're going to set up the classics. You know the models well at this point. We're going to set up the classic. You know the RAG pipeline well at this point. And we're going to do each of these retrieval methods. With that, I'm going to go ahead and pass it off to the man, the myth, the legend, the whiz for some advanced retrieval action. He's going to take it nice and easy today, walk through each one, algos, and all whiz over to you.
Yes. Okay. So this is the good stuff. This is the fun stuff. Just need to share my screen. We're going to look at basically everything that Greg just mentioned in a row. So it's gonna look like a lot, but it's gonna be worth it. The first thing we're going to talk about is our chain or our application. So you'll see there's a lot going on in the notebook, but uh, pretty straightforwardly, all we care about is there's a bunch of different cool embedding or sorry, retriever augmentations we can do, and that's it. So let's get started. Number one, you don't have to run this if you're running locally. If you're in the Colab, you'll have to uncomment and run the cell. Same thing with Quadrant. We're going to provide our OpenAI API key as well as our Cohere API key. And then we're going to get going. So first thing I'd suggest is making sure that we get our data, classic. The way that we're going to get our data is via the GitHub. So we have all these files saved on GitHub. They're just some CSVs. You can just download them, easy peasy. Then we're going to prep some data. We're going to basically just create a bunch of different documents from those CSVs. We're going to include some metadata because we want to, and that's going to be what it is. The next thing we're going to look at is the documents themselves. You see, pretty straightforward. You'll notice though that there are tons of reviews, right? So like the actual data that we're looking at today is just loads of reviews. So this is important because it's going to help us think about how we want to set up our retrievers, right? So we have loads of reviews of John Wick. Very cool, very exciting. Next thing we're going to do is, once again, we're going to set up our embeddings model as well as our vector store, easy peasy. Then we're going to create our naive RAG chain. This is just going to be a chain. You're a helpful, kind assistant. Use the context. If you don't know the answer, you're unsure, say you don't know. Provide our query in our context. Then we're going to leverage GBT 3.5 Turbo or 4.0 Mini. Up to you. We're going to use the default though, because it doesn't matter. We're just doing basic RAG. Just use the cheapest model that we can. They're all pretty good for RAG. Then we're going to construct this chain. All this is constructing a chain that lets us get back both our response and our context. This is going to be important when we think about how this chain works with Ragus. We need to be able to pull that context out, so that's why we have it here. Essentially, what you can do is you can look at the final response, and you can get both your response and your context. Nice and easy, lots of fun. Everyone's loving it. There we go. The next thing we're going to do is use our BM25 retriever. Our BM25 retriever is basically just keyword search. You can think of it as. But it's very easy. It's very straightforward. We don't care. Yeah, that's all that matters. I believe that I have pushed this to main on AIE 5, but if I haven't, very apologies, and I'll do so right now. We're going to go ahead and we're going to get our BM25 retriever set up, and the way we do this is extraordinarily easy. We just have to point to it, right? So it's going to handle everything behind the scenes. There is no additional work to be done. All you have to do is say that you want to use BM25, and away you go. You're using BM25. When we put this in our chain, you'll notice that we just substitute it for where our retriever was before. So if you see here, we have our naive retriever. We substitute it, and that's all we need to do. Once we've substituted it, this chain is now going to leverage this separate retriever process. So what we need to do essentially is just put in whatever retriever we want in the place of this retriever. This is not, so difficult. It's basically the idea. They're plug and play Lego parts, right? So we want to just make sure we are plugging and playing some Lego. Easy peasy. Okay. we're also going to look at the results of each of these, right? So our naive retrievers, whatever, we're not going to worry about that, right? Let's start with the BM25. Did people generally like John Wick? Opinions on John Wick seem to be varied. Some people really enjoyed the movie, appreciating an action sequence, silence, blah, 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 blah. Did any reviews have a rating of 10? If so, can I have the URL? And we get, yes, there was a rating with 10, and we get the actual URL, which is nice. Thanks, BM25 retriever. One thing that you'll notice, though, is that we're kind of cheating a little bit, right? So when we say what happened in John Wick, we get John Wick is a movie known for its beautifully choreographed action scenes and emotional setup. It stars Keanu Reeves and is highly recommended for action movie fans. This is something that's interesting because it does not really make any sense. And the reason it doesn't make any sense is that there is no keyword, right? For like what happened in John Wick isn't a keyword search. This is why BM25 is failing. So as we move to the next retriever, we're gonna get a little bit smarter, right? We're gonna get a little bit better. We're gonna figure it out a little bit easier. Okay. The next thing is compression, contextual compression. All that does is it takes context and it compresses it. There you go. So the way it does this is by some process, right? So we have to take some, say n number of documents and reduce those to some other, k documents. The way that we've done this before, and the way that we'll do it again today, is through re-ranking, right? So we're going to use Cohere's re-rank model, and this re-rank model is going to essentially take that big set of documents and then smush it down to a smaller set of documents. When we look at re-rank, again, we've talked about this before. We're going to talk about a little bit more in depth right now, but when we look at re-rank, effectively, it's the same process as embedding, right? The re-rank model. It's just using a large, expensive model. So what this means is that we're going to take our original set of documents. So this is our, the documents we retrieve with our cosine similarity using our embedding model. And then we're going to do the same thing along with providing a score using a bigger, slower model. And the question we often get is, well, why not just skip to the slowest model, right? Basically, the reason that we don't just use the slow model from the start is if we have like 10,000 documents, right? That slow model is going to be awful. So what we do instead is we use re-rank, where we cast a wide net with the, let's call it, not as great embedding model, and then we pass it off to the re-ranker, which is going to compress those documents. Now, the other thing to mention about re-ranking, it's called re-ranking, and it does rank the documents, but we don't care so much about the rank of the documents. Oftentimes, we just need there to be some number of documents, and their actual ordering is not super consequential. Now, this is not actually true of longer context, right? So once we get into, say, the 30 to 50 documents, suddenly the order does matter, right? And having that first highest value piece of context first is going to be preferred, or we're going to hope that it's floated near the top. There's some other quirkiness that you can get into as we get into longer contexts, but for now we're just going to leave it with it doesn't always matter that the best document is first, but sometimes it can matter. And so the re-rank, while oftentimes we don't care that it's actually providing a rank ordered list of context, it still is a useful side effect. Again, to use it, we just substitute it in, and then we can run the pipeline again. So we can say here again, the people generally like John Wick based on the reviews. Yes, generally they liked it. They found the rating of 10 as well as the URL. Very good job. And then we get a much better answer to the question, what happened in John Wick? Which is basically, this is the plot of John Wick. If you haven't seen it, spoiler alert, it's a great movie. You should see it. Okay. Next, we have the multi-query retriever. The multi-query retriever is very straightforward, okay? So what are we trying to do with retriever method, right? Well, we're trying to retrieve relevant documents to the user's query. Users are terrible at using systems, right? They famously, they'll use your system how you don't want them to. They'll put all kinds of weird stuff in. They'll try to use your system like Google, even though it's not Google, and they should not try to use it like Google, et cetera. So you get the point, right? The idea is users famously terrible at using the system the way you want. So what we do with multi-query retrieval is we put a little layer in between the user's query and the query that we use to fetch relevant documents. We say, hey, user, we know the user is going to ask something they want, but they're probably not going to ask in a way that's useful. So what we're going to do is we're going to take their query, and then we're going to generate n useful queries from it, right? This is going to do two things. Number one, it's going to make sure that the query is aligned with how we're thinking about retrieving information. And number two, it's going to be useful to kind of expand a little bit let's call it the perspectives we're looking at, right, from the user's query. So the user might ask something like, well, how do I, well, for instance, people might ask something like, did people generally like John Wick? Well, that question has a lot of subtext, right? There's like, well, did anyone not like John Wick, right? Did most people enjoy the movie or rate it highly, right? So there's all kinds of different ways that we can formulate this query to kind of increase the coverage of our data. And that's exactly what this multi-query retriever does. Setting it up couldn't be easier. We simply use the multi-query retriever from LangChain. We give it our naive retriever, which is our basic dense vector search, as well as a chat model. The chat model is going to reformulate the query, produce more queries, and then we're going to plug it into our retrieval chain. And then we get these responses. Now, interestingly, the multi-query retrieval, right, did great on the questions that were more subjective, but didn't do so good on the just retrieve the correct response measure, right? So what this means is that this query is strong from where we're really trying to leverage that semantic similarity pipeline, but it falls short when we're trying to just extract information as we would in a traditional search search application. Next is parent document retriever. Greg's talked about this already. It's very straightforward. The easiest way to think about this is like a textbook, right? In textbooks, we have equations, and then around those equations, we have stuff that's relevant to that equation, right? So if you search just for the equation, you're going to get the contextless equation. So instead, we're going to bring along all that stuff that surrounds it, all that useful context that surrounds it. All this looks like in the code is that we're going to create two methods of retrieving information. One method is going to be dense vector search, as we're used to, and then the second one is just going to be a lookup. So what we're going to do is we're going to associate a number of chunks with each other, let's say, right? So like, let's say we have this paragraph, right? Or this bulleted list, right? Well, let's imagine that each of these would be a separate vector, right? In a child document, we could say, of this entire parent document. So when we're looking through these documents, trying to retrieve the correct one, our dense vector search might find this vector and say, okay, we're gonna take this. This is a good chunk, right? This is a chunk that's close to the user's context. And then instead of just vomiting that back, we're going to pull all the other stuff that it's associated with into the context window. So very useful when you know that you have documents or information that is embedded in other useful contexts. So how do we do it in code? Basically, we set up two things. We set up our parent documents as well as a child splitter, which is very, kind of gruesome language, but the idea is that this is going to create our children documents. Then we're going to create a collection in quadrant. This collection is going to be the full documents. You can imagine that those are just the full documents. Then we're going to create our parent document retriever from LangChain. We're going to provide a store. This store is going to be what holds the reference of the parent document along with the child documents they're associated with. The way that it'll work in practice is that we will retrieve some child document using dense vector search, and then we will associate that through metadata with the parent document, and then we will pull the parent document as context for the LLM. It's easy to set up. There you go. And then plugging it in, same as always, we just plug it in for the retriever, and then we can ask questions. Once again, based on the reviews provided, opinions about John Wick seem to be divided. Some people like the series, while others have strong negative opinions on it. This is the first one that caught that anyone didn't like the movie John Wick. A very good parent document retriever. We do get the 10 with a URL, and then we get a suitable answer for what happens in the movie. Again, spoilers, but there you go. It's an old movie now, so no big deal. The last thing we're gonna do is, what if we just did all of these, right? So we're gonna ensemble them together. Greg talked about the reciprocal rank fusion algorithm. The idea is we're just going to say, hey, use all of these, get the documents that each of these methods provides, and then fuse the lists into a rank ordered list, right? So what this will do is it will take the results of retrieving each of these retrievers separately, and then it will give them all equal weighting because we've said to, and it will retrieve the documents, and it will combine them into one big meta list that will feed into our context to produce our response. As you can see here, this is very straightforward to use. Again, we just plug it in. It's the same every time. And then we can see we get great great responses overall. We get the majority of people really liked it, the accurate sequence. However, there were some negative reviews. So not only do we get, that everyone loved it, but we also get the flavoring of some people, in fact, didn't like it. We get the 10, everyone loves that, and then we get a decent summary of what happened in the movie. Okay, so there's one more strategy. Now, this strategy is independent of the other strategies in that it's not a kind of retrieval. It's actually a way to chunk. Greg already showed us with Alice in Wonderland book, but basically this is semantic chunking. Semantic chunking just keeps all of the parts of the document that are close in meaning together, right? So instead of guesstimating, well, paragraphs should be associated with each other and chapters should be associated with each other and this kind of thing, we're going to just use math to help us determine, when a chunk is distinct from a neighboring chunk, and that's that. The way that this is done under the hood is extremely straightforward. We get the semantic, or we get the embeddings for each of the potential chunks. We look at see if two neighboring chunks are close together as determined by some threshold. If they are, we merge them. If they're not, we create a split. That's a new document. That's all that happens. It is, however, fantastic. It is partially fantastic because it is expensive, right? We're doing a lot more embedding. We're doing a lot more computation, but it's great. It works. We can use it. And again, most people like John Wick. We get a review with a 10, and John Wick is an ultra-violent movie. So the idea of this first breakout is just to go through the different methods, implement them, see how they work, try your own questions, right? But that's the idea. With that, I'm going to pass you guys back to Greg, who will get us into our first breakout room so we can get coding.
Nice. Yeah. Ultraviolet. Dig that. Hard agree. Okay, guys. Try to have some fun here. We know you guys have been working hard on the midterm. This should be right in your wheelhouse. You're going to build a RAG thing. You're going to pull out some John Wick data from a repo that we put together. And then you're going to try out some different algos. And, enjoy the discussions, enjoy each other's company, complain about the midterm if you need to, whatever. And we'll see you back in 25. This is going to be kind of a build-focused session for the rest of the day. So, kind of relax into it. You got 25 minutes. We will take kind of a late break today, but we will give you a solid 5-minute break, do some QA in the middle. Maybe we'll even have a few minutes at the end for QA. So Breakouts, back to journey groups. Getting back into it, guys. 25 minutes. We'll see you soon. Back from breakout rooms, back from the break. Wiz, I think it's real simple what we're asking them to do today, right? We already talked about it earlier. We've talked about it much throughout this entire, second, sort of half of the 7 weeks. We've talked a lot more about evaluation. And, that's really what this is all about. We have all these different retrievers now. We got all these tools in the toolbox. We got the kitchen sink. How do we know which one we should use? We can go and we can say something like, oh, we should use keyword search and we should use dense vector retrieval, or we should use hybrid approach. But really, it's always better to decide for yourself, right? It's always better to sort of evaluate it yourself. And that's what we're asking them to do today, right?
That's right. Yeah. It basically, we've talked about this a lot. We've done it a few times. It's just time to put the pen to the paper and get it done. And that's what we're gonna do.
Just to be real specific here, this is the activity. And this is actually enough for you guys now. And that's how far you've come in just 7 weeks. And I think again, this is one of the last final things that you're going to try to do is really optimize, get it to that kind of human level performance before you say, okay, let's ship this to production. And we'll talk more about what ship to production means. It means make it scalable, make it safe, make it open source, make it, so you can put proprietary information in it. It means, and align it with your users. And, there's also an advanced build here. I don't know if you want to talk about the advanced build for those that are interested. This should be plenty. But the key here is you don't have to do everything in the breakout room, but you should map out as a group exactly what the strategy would be to, quote, evaluate the different retrievers with Ragus and for what. This is the essence. And then maybe you can tell us what RAG Fusion is before we head to breakout rooms, Wiz.
Yeah, and so I'll just share the screen really quickly. We have some additional context for you in the notebook in terms of what we need to do. Basically, we're going to create a golden data set. So a data set we're going to use to evaluate on. We're going to use synthetic data generation to get that, powered by Ragus or otherwise. And then we're going to evaluate each retriever with retriever-specific Ragus metrics. So this is going to be the things that pertain to retriever, right? So answer correctness, not necessarily going to make sense here because we're looking to see why this is a good retriever pipeline. Separately, what we're going to do is we're going to write a short paragraph about, which is best, etc. And then, just to double note it, this does not have to be done in the breakout room, right? You should work with a peer supporter to come up with a plan, of course, but, don't feel as though if you're not done it by the end of the session that you're behind. It's just meant to be kicking you off to do the thing that you're going to be expected to do a lot of times when you're building applications with AI.
That's it, guys. We're going to just head back to breakout rooms and do some evaluation with Ragus. When we come back, we should be able to chat for a few minutes. If you guys have questions about retrievers, if you have questions that you want to chat about more generally, and then we'll go ahead and align ourselves towards the very last session of our prototyping part of the course. And we'll foreshadow a little bit about what's to come in the production part of the course that kicks off next week. So back to breakout rooms we go. 25 minutes. Evaluate time now that we've built. Back from breakouts, it's time to wrap up today's session. We hope that it was a little bit of a reprieve, but also a nice way to go deep and bring stuff together. Remember, when we're building RAG systems, we have something we're going to ask. We have some input we're going to provide. It doesn't have to be a question. And we're going to do some retrieval. We're going to get some data, put it in context. It's all about finding the best chunking and retrieval strategies to get us where we're trying to go. To balance performance and cost, we want to understand that we need to balance information retrieval, classic approaches like keyword search, as well as looking at semantic meaning of the right sized chunks. Want to always be baselining, want to always be looking at directional improvements, but also importantly, do not forget to talk to real people about this thing you're building, see if it's useful to them, and always be down scoping the project scope. We often try to solve meta problems, and you're going to need a lot of metadata and meta context to solve the meta problem. If you can zoom in enough, you can get the right data for the right problem. The fine lines are important to keep in mind between chunking, between retrieval and ranking. They're all related, and you're the expert. You're going to have to teach people how they're related. Next time, we're talking open source deep research. This was a new drop from LangGraph. We don't typically do brand new drop stuff in class. In fact, we almost never do this unless we're going to run an event on it on YouTube first. But since we kind of already covered open source deep research in small agents in the Hugging Face framework, we thought, it just really does fit for our advanced reasoning session that we wanted to do in this cohort to build it with LangGraph. So we've got a few minutes. If you have questions, we'd love to answer them before we get into feedback session today. I don't see any in the chat, but I just want to leave a little bit of space in case there were any from anybody that you're dying to get an answer to. Wiz, I have a question. Do you think your supporters nailed it today? Because we have no questions.
I always feel like they've nailed it. So it's not surprising.
I guess it's not. Okay. Nick, what you got?
Yeah, on the parent versus child on the retrieval strategy. So as I understand it, like let's say I'm trying to look at a stock's performance and I got a bunch of 10Ks and I want to say what's the 2024 year-over-year revenue growth. I'm going to go first find that chunk that says like that embedding of revenue growth is this. That's the child. And then it says now that it's found the kid, it's going to find the parent and pull together all the other relevant chunks to like enrich that response if it determines that this answer needs to be like from that single doc. Is that I'm trying to understand like the best practice for like one, do I have the child and parent dichotomy right? And then two, what's best practice for like trying to enrich the context of a more specific question?
Yeah, you have the idea correct, so that's good. I would say like what we want to see happen is it's the meta problem, right? Where it's like, well, how do I chunk the parents then? We're gonna largely just believe that this is less important because we're using longer context models, and we're just gonna keep together like coherent pieces of the document. So chapters, what have you, sections, depending on how your documentation is parsed out. There's not like a hard and fast rule for like, what should I use necessarily for like optimizing the parent chunks versus the child chunks.
Got it.
Yeah. So if I have like, well, I guess if I have chapters and I have natural breaks in my documentation, I should go ahead and just label that metadata as I'm, if I have a data team, let's say, and I want them to be prepping data for useful, applications to be built later. Is that something that, I should be recommending is just, labeling as much metadata that I can? What's the right way to think about this?
Is that where like unstructured kind of abstract some of the difficulty there, or like llama parse would do that depending on the doc type? It's like, hey, this is a 10K. We know that there's this like natural set of headers, subheaders. This is relevant metadata for that. Or like Slack would be time, channel, person, right? Like, so it's kind of doc dependent and source dependent. No?
I mean, all of these methods are frustratingly doc and source dependent. It is like it is just the way it be that without, so this is why we make the joke, right? Like data science isn't dead, because all of these questions are hyper specific to your data, and just require like experimentation understanding. There is no, and I hate to say the phrase, but like there is no shortcut here. Like it's just, it comes down to what we did today, trying things, evaluating them, understanding what things work better, and then, you know, we're gonna, let's say we wind up with parent document retriever being the best, then digging into the hyperparameters that we have there, digging into the things that we're talking about. It's like you have to follow the metrics, right, in order to get to something that works for your documentation. Again, understand it's frustrating because there's not an answer, but there really isn't. People call this like the black art of chunking and stuff like that, and it's no less true in 2025 than it was in 2024. Like that's where we're at.
But I
People
do
are
think
working on it though.
I do
People are
think
working.
like, you know, if you think about Demo Day, you think about Llama Parse, you think about some of these tools, it's like you guys could be starting to build out the tools that are the document specific, you know, experts, you know, and people will have to build out collections of these tools, whether they do it internally or whether you do a startup with it and you create a bunch of tools together and you start acquiring other tools. Like somebody has to do the work, and until somebody does on like a sufficiently specific thing that enough people have a problem with, you know, I don't think 10Ks falls into that category, but I'm sure there are internal tools at, you know, large financial institutions to do this. So good question. And we're going to keep it moving because we got feedback time. Remember, you can find your peer supporters in office hours. Check us out tomorrow with Cursor. We're dropping the feedback into the chat. And if you want to go deeper on advanced RAG stuff, on advanced chunking techniques, then Vincent's deep dives are next week. Thanks everybody that joined him this morning. We're going to put 2 minutes on the clock, and we'll owe you 1 minute back, but hopefully that's okay given the chillness of today and last week. Vibes incoming here. Okay, everybody, thank you so much for joining us for session 13 on advanced retrieval and chunking techniques for RAG. Next time, we're going to talk advanced agents and advanced reasoning with LangGraph. We're also going to mix in some of the more fun, more reasoning, more state-of-the-art stuff that we've been chatting about on YouTube, in case you haven't caught all of those. It'll be a little bit of a discussion. It'll be a little bit of a sort of quite advanced build. It should be a lot of fun on Thursday, and it'll really, really be out to the LLM edge. On Tuesday next week, we kick off our production part of the course. Now, full disclosure, production is a little bit less sexy, a little bit more boring in some sense, you might say, than some of the prototyping stuff. So bring the energy on Thursday, come for the hype sesh on reasoning and super agentic stuff. And then on next Tuesday and through the rest of the course, we're going to focus in on some stuff that really will help move the needle for your enterprise. And hopefully that stuff resonates with you guys and where you're trying to go. Thanks again for joining us, session 13. We'll see you for session 14, Advanced Agents and Reasoning, on Thursday, hopefully tomorrow, for Cursor. Bye, guys. Have an awesome evening.
Joe.
Later.
Bye, everyone. Bye, Little Vanilla.
Bye, everyone.
Little Vanad. Hey, buddy. Hi. Oh, is he a little shy guy?
Bye.
Bye.
We see you. Thanks for joining us, little man.
You can hang out with us anytime.
Yeah, 100%. All right, guys. Catch you later.
Bye, everyone. See you Thursday.